Okay, this is lesson 41, graphing quadratic functions. So this lesson is the same as yesterday's, except it's a little harder. And so yesterday I didn't have my technology working, but today I do, so we have a recording. So if you missed yesterday's lesson, then you could still see today's lesson, and it's the same thing, just a little bit harder problems, okay? But the same process, same steps, it's just a continuation. Okay, and the big picture of what we're doing right now is that in Algebra 1, we're looking at three kinds of graphs. Okay, so if I had, my x and y axes, and I were to, alright, so if I had, graphs from the beginning of the year, we were looking at three major types of graphs. The first type of graph we were looking at was called a linear graph, so it looks like a line. This is called linear. Okay, we learned how to graph that. The form of that equation was y is equal to mx plus b, right? We all know how to do that, right? Okay. Now we're looking at quadratic graphs. Quadratic graphs could either look like a U, kind of look like a U, but they don't look totally like a U. Or they could look like an upside down U like this. Okay, both of these separately are called a quadratic. Okay, so actually I'm going to erase the bottom one because I just want one of them. This is called quadratic. And the form of this we learned yesterday was y is equal to ax squared plus bx plus c. Okay. So we needed it, that's the standard form, we needed it in order to graph it, okay? There's other ways to graph it, you'll learn in Algebra 2, but in Algebra 1 this is all we need to know. And then the third type of graph at the beginning of the year, what did we teach you? What was the form? Exponential, right? So we have exponential growth or exponential decay. So now we're looking specifically at quadratic graphs. Okay, so we're looking at the middle one. So we already know linear. We know I have arrows at the end here. We know linear. We know we're learning quadratic. Okay, here are the steps from yesterday. They're the same as today. So we need to put the equation into standard form. You identify a, b, and c, and then you have to find negative b over 2a. Then you use a table to find 2 points in each direction from the vertex. Solve for y for each x, right? When we solve for y, that means like find the output with each input. And then we plot the points. And then we draw a U-shaped curve. Okay, so I'm going to do numbers 1 and 2. Today's a little harder. Today's going to be, we're dealing with points that are going to be like not perfect on the crossings of the graph. Or also we might be even dealing with fractions today. So we have to be really careful when we deal with these. Okay, so here we go, number 1 and 2. Okay, watch right now. Everyone's watching. Okay, first thing I want to do is when I'm graphing this is I'm thinking, is this in standard form? Okay, you see how the numbers are bigger today? Okay, so number 1, numbers are bigger. Number 2, the numbers aren't bigger, but it's a little tricky on number 2. So number 1. It's in standard form, so we know a is equal to 2. We look at the coefficient in front of the letter, so we're just looking at 2. A is equal to 2, b is equal to 12, and c is equal to 19, okay? Then we need to figure out what our vertex point is, so we write negative b over 2a on the side to find out where it is. We plug in b, we have negative b, so negative, we don't know what b is. We're going to look at our equation. B is equal to positive 12, so it's going to be negative 12 all over 2 times a. Sometimes b is negative, sometimes a is negative, so you have to be careful. So we got negative 12 all over 4. And then we think, what's negative 12 divided by 4? It's negative 3, right? Negative 3. So this becomes our vertex x-coordinate. So that's the input. So how do we get the output? You take negative 3, plug it back into the original equation. So this is where things get a little scary, but trust me, if you get really big numbers, then you're going in the wrong direction, okay? So we have to go very carefully. We plug in negative 3 whenever we see x's. So negative 3 squared, if you look up here, negative 3 squared is 9. 9 times 2 is 18. Okay. Then we have negative 3 and a positive 12. Negative 3 times 12 is going to be negative 36. And then we have plus 19. Okay. So now we have to calculate this. We have 18 minus 36 is negative 18. Negative 18 plus 19 is positive 1. Okay. So that's where our vertex point is. So that was the side problem. Now I'm going to erase that so that next time I don't have to write that down. Now I'm going to draw a table, an XY table, and the way you do that is you just draw X and Y and draw like a cross underneath that. And then we put, since the vertex, we know that our parabolas are symmetrical, the vertex is in the middle, so you got negative 3 and positive 1 in the middle. So what's two bigger numbers than negative 3, everyone? What? Negative 2 and negative 1. What are two smaller numbers?
Negative 4 and negative 5.
Good. Okay, so are they always the same inputs on each problem? Are you noticing they're the same? Are they the same inputs on each problem? No, they're different, right? It depends where the vertex is. Okay, now we plug it in. Now we're going to plug in negative 2 into our original equation so that wherever we see an x, we're going to plug in negative 2. So we got 2 squared is 4. 4 times 2 is 8. Then we got negative 2 times positive 12 is negative 24 plus 19. Okay, so we have to think about this. 8 minus 24 is negative 16. Negative 16 plus 19 is positive 3. Okay, so we're going to put a 3 here. Now we're going to erase that work and put in the next input, which is negative 1. Okay, put negative 1 here. So negative 1 squared is 1. 1 times 2 is 2. Then we have 12 times negative 1 is negative 12 plus 19. Okay, so now I calculate this. 2 minus 12 is negative 10. Negative 10 plus 19 is positive 9, right? Is that right? 2 minus 12 is negative 10 plus 19 is 9. Yep. So we plot that point right there, okay? Now we know that quadratic equations are symmetrical. So this point, or this number 3, we're going to copy right here next to the 4, and this number 9 we're going to copy right next to the 5. Okay? And these are all my coordinates. So we take negative 5, negative, or positive 9, we're going to plot that. Okay, the next one is negative 4, 3. Plot that one. And then we have negative 3, 1. We have negative 2, 3. And then we have negative 1, 9. Okay. So the last step, we're going to draw a U-shaped curve through the points, and this is the hard part. We do not want it to look like a V, okay? And of course you draw arrows at the end because we could pick more inputs and it would go on actually forever in each direction. Okay, so that's how we do number 1. Any questions on number 1? Yes.
How did you get positive 1?
Here,
Yes.
if I put in negative 3, look at the original, negative 3 squared, so students asking how did I get this positive 1 here, you take this negative 3 as an input into the original equation, so negative 3 squared is 9. 9 times 2 is 18. And then we got negative 3 times 12 is negative 36 plus 19. Are you following so far?
Yeah.
Okay, and then we add them together. Negative 18 plus, or 18 minus 36 is negative 18. Negative 18 plus 19 is 1.
Okay.
Okay? Good
so
question.
You just replace all the x's.
Mm-hmm.
Right.
Right, because all of your x's are the ingredients, right? This is our math machine or the function. So whenever you put a number in, you're going to pop out another number. Does that make sense? Okay? All right, watch me do number 2. I'll go a little more quickly. Number 2 is a little bit scarier. It doesn't look scary, but sometimes you get scary ones like this one. So, okay, so number 2, it's in standard form, so we're good. Then the other part of step 1 is figure out what your A, B, and C is. A is 1 because there's no coefficient. We assume it's a 1 there. B is 3, and C is 3. Okay. Okay, so continuing on here, so we figured out a, b, and c. We have negative b over 2a to find our vertex. B, remember, is positive 3. So it's going to be negative 3 over 2 times a. So it's going to be 2 times 1 here. Okay, so negative 3 over 2. Can I simplify negative 3 over 2? Yes or no? No. So now we have a fractional vertex. It's going to be a little bit harder. So we have negative 3 halves. Okay. Now to get the output, watch carefully, we have to plug this back into here. So negative 3 halves is like saying 3 squared, or negative 3 times negative 3 is 9, or 2 times 2 is 4, so we get 9 fourths. And then we have negative 3 times 3 here is going to be negative 9 halves plus 3, okay? Now we have a fractional problem. We know that 9 fourths and negative 9 halves don't have a common denominator, so I have to find one. If I were to change our denominator to 4, then this one would be times 2, which would be 18. So 9 minus 18 is going to be negative 9 fourths plus 3. And we know 3 is just like saying 12 fourths. So I know our vertex is going to be negative 9 plus 12, which is positive 3 fourths here. Okay, so our vertex is at 3 fourths right here. So we're going to plot our vertex now. Actually, we're going to make our table. You see how crazy some of these get all of a sudden? So we got negative 3 halves. And our output is 3 fourths. Okay. Then we have to pick 2 smaller numbers and 2 bigger numbers. So what's one number that it's a little bit bigger than negative 3 halves? By the way, what's negative 3 halves? What number is that? What's that? Negative 1 and 1 half. So what's a number that's a little bit bigger than negative 1 and 1 half? Negative
1.
Negative 1. Good. So we're going to pick negative 1. What's a number that's a little bit bigger than negative 1? 0. Right? What's a number that's a little bit smaller than negative 1 and 1 half? Negative 2, right? And then we got negative 3. Did you all catch that? Okay, so you have one fraction here. It's kind of scary, right? Now we have to plug these in. Let's put negative 1 in, okay? So whenever I see x, we're going to put negative 1 in. So we got over here at the very top, 1 squared is 1, and then we got, I'm sorry, negative 1 squared is 1, and then we got 3 times negative 1 is negative 3 plus 3. So 1 minus 3 is negative 2. Negative 2 plus 3 is 1. So whenever I put in negative 1, I get the answer is 1. Okay? Put 0 in now. 0 squared is 0. 3 times 0 is 0 plus 3. What's 0 plus 0 plus 3, everyone? 3, right? Okay, and we know it's symmetrical, so we're going to copy this here. 1 and 3 on the side. Are you all following still? Yes? Okay. So just like yesterday, plot these points. Negative 3 halves, 3 fourths. So it's negative 3 halves is negative 1 and a half right here. And we go up 3 fourths, which is about right here. Okay, then we plot a point at the other ones, negative 2, 1, negative 3, 3, negative 1, 1, and 0, 3. Oh, I plotted these wrong. Let me fix these. Sorry, it was negative 3 up 3, so we're going up to here, and 0, 3. Okay? See how we have a shape here? Is this one wider or more narrow?
Wider.
This one's a little wider. Okay, so draw our graph. We're being very careful. Draw some arrows at the end. And we're done. Okay, so this kind of problem is a little bit harder. Sometimes you have to deal with fractions, but you could get through it. As long as you take the steps, you'll be all right. Okay? Any questions so far? All right. So let's have writing the equation down for number 3. Don't worry about number 4, just number 3. And actually, I'll hide number 4, so we have a little more room to write. Okay? Okay, so is it in standard form, everyone? Yeah, it is. What's A equal to?
4.
B equal to?
8.
C equal to? Okay, good. So now we're going to write the next step, which is finding what? The vertex with negative b over 2a. Good. Okay, so we got negative b over 2a, which is equal to negative b, so we have negative 8 over 2 times a, or 2 times 4. Okay. So we have negative 8. What's 2 times 4, everyone? 8. Good. What's 8? Negative 8 divided by 8. Negative 1. Okay. So we know our vertex is going to have a point of negative 1 something. Okay. So on your paper, now we have to plug in negative 1 into our equation. So looking here, this is what you should do on your paper. When you have to plug in numbers, look up here before you write it down. I'll give you a moment to write after I do one of them. You should take the equation y is equal to and plug it in. So it's going to be y is equal to 4 times 1 squared plus 8 times 1 plus 5, okay? So we got 1 squared is 1, times 4 is 4, 8 times 1 is 8, plus 5 is equal to 12, 17. We did something wrong here. Oh, I didn't put a negative sign there. Sorry about that. Let me fix this. Okay, there should be, sorry, before we did that calculation, there should have been a negative here. So we have negative, negative. Again, we're plugging in negative 1 to whenever we see x. So, starting again, negative 1 squared is 1. 1 times 4 is 4. 8 times negative 1 is negative 8 plus 5, okay? All eyes up here. 4 minus 8 is negative 4. Negative 4 plus 5 is 1. Okay, so our vertex is at negative 1, 1. Are you all doing this along with me? Okay, this isn't just a show. This is a really hard topic, so you have to focus during this time, okay? Okay, so negative 1, 1 is our center of our graph, okay? Everyone, what are two bigger numbers than negative 1? 0 and 1. Okay, good. Okay. What are two smaller numbers than negative 1? Negative 2, negative 3. Okay. So all we really need to focus on are these two numbers here now, because we know that once we get these, we could copy them to these respectively. Okay. So let's put in 0 now. Okay. So we're writing the equation out. You would write this on your paper. Y is equal to 4x squared, but instead of x, we're using 0 as our input. You watching this, Patrick? You seeing what we're doing?
Yeah.
Okay. Plus 8 times 0 plus 5. Okay. 0 squared is, what's 0 squared, everyone?
0.
Times 4?
0.
Good. 8 times 0 is? What?
0.
0. What's 0 plus 0 plus 5? 5. Okay, that's an easy one. So we're going to put 5 here. Okay. Again, y is equal to, now we're going to plug in 1 into our equation. So y is equal to 4 times 1 squared plus 8 times 1 plus 5. Okay. Okay, 1 squared is? 1 times 4 is 4. Good. 8 times 1? 8. Good. Okay, what's 4 plus 8 plus 5? 17. Okay. Okay. So now we copy these. We know it's symmetrical, so we're going to copy the 5 here and the 17 here. Okay. Now what do you notice about these numbers? They are pretty big, right? But our graph is going by 2's, right? Look at the scale of our graph. Do you notice how it's not going by 1's but by 2's, right? So we're going to go graph our we're going to graph our vertex first, negative 1, 1, okay, which is negative 1, 1 right here. Okay, then we have negative, or 0, 5, so we're going to go 0, 5. And notice how these points are not perfectly on the graph, so why don't you graph these on your paper, please, on your iPads now, okay? Yours should look like mine, but on your graph. We got negative 2, 5, and then we have 1, 17, which is right in the middle up here, and negative 3, 17. It's way up here, and we're going to graph it. This is a very narrow graph, probably because of the scale of the graph, but it's because our coefficient is 4. Okay, so I want you to graph this right now. This should be a negative 1 down here. Not sure why I did that. Alright, so this one takes a little bit more work, and notice how some of these points, the reason why we did this example, look at how these points on this graph, they're all not like crossing the lines. You have to like count in between because this graph is going by 2's. You all see that? So you have to count carefully. You can't just count up each box. So the scale is differently. Alright, let's do one more. Alright. Let's go jump down to number 5. Okay, number 5. We'll go a little more quickly. Please write down number 5 on your notes. iPad should be off right now and face down. You are not supposed to be on your iPads right now. iPad's off and face down. Starting up, what do you notice about this graph? A is equal to what? Negative 1. So since it's negative 1, we know it opens up or down? Down, right? B is equal to?
3.
C is equal to?
Negative 4.
Okay, good. So these are smaller numbers, so that's a good sign, but smaller numbers can also mean we might run into some fractions here. Alright, so we start with negative b over 2a. So I'm going to write that on the side. So we got negative b. Our b here is 3, so it's going to be negative 3 over 2a, and our a is negative 1, so it's going to be 2 times negative 1. So we have negative 3 over negative 2. What's negative 3 divided by negative 2? What's a negative divided by negative to start with? Positive. So our answer should be positive, so it's going to be positive 3 halves, right? Positive 3 halves. That's where our vertex is, okay? So we have a fraction here, so I'm going to write that on the side. So that's our ingredient now, okay? That's our ingredient. So how do we get the output if we have 3 halves? What do we need to do? Plug it back in. So we take the original equation, y is equal to, and then we have negative x squared. So instead of x, we're going to put 3 halves squared plus 3 times 3 halves plus, or is that a minus or a plus 4? Plus, oh, minus 4. Okay, so we just copied this equation with the input of 3 halves. So 3 halves squared I know is 9 fourths, because 3 times 3 is 9 and 2 times 2 is 4, and we have a negative sign in the front, plus 3 times 3 halves is like saying 3 over 1 times 3 halves, which is just like saying 3 times 3 is 9, 1 times 2 is 2, minus 4. Now we're trying to find a common denominator out of all of these, so the common denominator is 4, so we have negative 9 fourths, plus 18 fourths, minus 16 fourths, okay? Negative 9 plus 18 is positive 9 over 4 minus 16 fourths. 9 minus 16 is negative 7 fourths, okay? So our vertex is at negative 7, or 3 halves, negative 7 fourths, which is like saying 1 1/2 and down almost 2. So you're going to go 1 1/2 and then down almost 2, 1, 2, but a little bit before, so you're going to go like right about there. That's your vertex. Okay, what's one number that's a little bit, oh sorry, let's go draw our table before I ask this question. So we have a vertex at 3/2, negative 7/4. Okay, what's one number that's a little bit bigger than 3/2? 2, good. What's the next bigger number than 2? 3, good. What's one number that's a little bit smaller than 3/2? 1 and 0. Okay, I got a question. Would you rather work with 2 and 3, or would you rather work with 0 and 1? 0, 1, right? Couldn't I copy these directly down here anyways, right? Since we know it's symmetrical. So we're going to go the easier route. So let's plug in 0 into our graph. So we have y is equal to negative 0 squared plus 3 times 0 plus, or I'm sorry, minus 4. So we got 0 plus 0 minus 4, which is all equal to negative 4. So we're going to put negative 4 here. And while we're at it, we'll copy it at the bottom. And then we have 1, so we're going to put in y is equal to negative 1 squared. I hope you're all working along right now on your papers. Some of you aren't, so you run the risk of staying after class or getting a bip. You writing this down? Plus 3 times 1 minus 4. So we got 1 squared is 1 times negative sign is negative 1 plus 3 minus 4. Negative 1 plus 3 is 2. 2 minus 4 is negative 2. So we're going to put a negative 2 right here. Okay? So we have all our points. I want you to graph them for me. I'll plot some. So yours should look like mine. Please pull out your iPads. You should plot your points like mine. With the graph, okay? And I know I'm doing a lot of the work here, but I want you to see every step.